All right, Lady Ada, what is this?
I'm glad you asked. This is Show and Tell. I'm Miss Lady Ada, would be Mr. Lady Ada. Back to being the OG hosts. Thank you so much to the
We're back.
who were hosting Show and Tell for a couple of weeks. We had so much stuff going on at Adafruit. We just needed a little bit
We had
of
a ribbon cutting. We had a bunch of activities going on. Getting Adafruit in a great spot so we can continue to make hardware and more. It just required that little extra bit of time because we kind of go down to the wire. It's like, okay, Lady Ada, get off EagleCAD, come over here now.
No, you told me like stop designing hardware.
Stop designing. Take a break from hardware for a minute.
Okay. Anyway, Show and Tell, our favorite 20 minutes of the week. We're gonna check in with Adafruiters, people from the community. What do they have? Soldering, whatever. Come on by. We're in Discord. Anybody's welcome. You don't have to be working on Adafruit Electronics. It can be like anything cool that you're doing or you're thinking about doing.
And speaking of, it is Shacktoberfest. So if you take a look at our blog, we're celebrating kind of the history, memorabilia, memories of Radio Shack. There are still some Radio Shacks. We'll talk about that on Ask an Engineer later. But if you have like, a cool piece of technology that you've been saving, I gave the example. I was talking to our team today. When I founded Hackaday, the first post I did was about a tone dialer. And I remembered the magical experience of putting in a little crystal and then being able to make free phone calls.
I did the same thing. I remember ordering
it was like, this is what I want to do.
1-800 Mauser. I think it was a key on the phone because you didn't have no internet. You can order, and I said I want a 6.5536 megahertz crystal.
Yeah.
I want 10 of them, and I was like really worried they would know what I wanted it for.
You're gonna be put on a list.
Yeah, but they were like, anyways. And then I guess I don't know if I paid with a credit card or COD. I have no idea how I did it.
Back in the day, COD, probably had a money order waiting.
I think I had a money order. Yeah.
So anyways, I still have the tone dialer that has the soldered in crystal. So anyways, maybe we'll show that off if I can dig it out of boxes because we just moved the company and us personally. But on to the Show and Tell.
Not reminiscing. Scott, what are you up to?
What do you got going on?
Oh, I'm just working on CircuitMatter like I have been for weeks on end.
Yeah.
It's quite a complicated thing, but I feel like every week I say I'm getting closer to making a light that turns on and off, and I feel like I'm making progress. Last week I showed that I think I showed that on iOS I wasn't fully commissioning, and I figured out an issue with that after I discovered a test app that's super helpful. And now I'm trying to, I just did a run with Apple Home from my phone. If you pull up the window.
Okay. You want us to pull up yours?
Yeah.
I have terminals.
At the stage.
Okay. To catch people up, Matter is a protocol that all the big companies agree to support. If you have something like a HomePod Mini or a couple other devices in the Apple ecosystem, or there's, I think,
Google Home.
You have to look.
Samsung has it as well.
You have to look which one it is. But basically, you can start to do things that say, like, Matter. I have some Eve stuff that I'm trying to get to work. But it must be simple because getting it to work is so complicated.
Yeah. But a lot of the complexity comes from trying to be secure, which is a good goal.
Yeah.
And the other complexity comes from it was very clearly put together by different committees. And so, like, they say, here's our architecture diagram, and here's all the different layers.
Yeah.
And those layers say, this layer was designed independently of the other layers, right? And that's because it was a different committee for the different layer, and then they come back together and they rectify it. And so you get kind of weird things like the underlying encoding has a list type, but then like the top, like 3 layers up, there's also a list, but that list is encoded with an array, not a list, and it's just like, so I'm working my way through those weeds, and they have access control and stuff. I think a third thing that makes it interesting is that it seems to be very distributed. So if you say like this light switch turns on this light, like it's the light switch that talks to the light directly. There's no like intermediate thing that it has to go through. But it means that there's a lot more state that you maintain on every device, right? So I'm working on that. What I have here is one of the things that Apple Home does is they're trying to add access control settings. So if you let anything talk to you about something, then you need to actually know which things can talk to you or not. So I'm working on handling a write request. So this is a write request, and it's first trying to set it to an empty list, and then it's trying to append to it. So I'm making that work right now. I'm not actually going to enforce the access control list, but I'm at least like adding this. So the layers that I'm in right now is one is the data model, which is like you have clusters, and clusters have attributes and commands that you can run on them. So for example, there's an on-off cluster for turning something on and off. There's a on command and an off command, and there's an on-off attribute that tells you whether it's on or off. So the interaction model is what tells you how to interact with the data model, which is the attributes and the commands. So that's the layer I'm in right now. This is the first time I've had a write of an attribute. So I'm implementing writing attributes in the interaction model layer.
Okay.
I know, it's insane. And there's also subscriptions.
It's like you're 7 layers
But this is why people like Adafruit.
Ring the bell.
Well, this is why they like Adafruit, because eventually we're going to have a board that does a lot of the stuff in a library, and you'll be able to just say what you want to do. Like, we take all the complexity and like, okay, like here's how you do it. And eventually you get like a feather that'll just do this.
Right. So I was kicking around the idea of like, oh, you want to make a light. You just subclass the light class and then implement on, and then that on function gets called when it turns on. That sort of thing. So yeah, that's where I'm at, which is exciting. But there's just all these little details. On the customer's or consumer side, user side, like we do this for a living, like we're really good at this. And I can get the Eve sensor that I have that I'm trying to test work at one location, but not another. Everything's identical. Okay. Same type of home kit setup, same Is it the same physical device that you're moving between two places? Yeah. If it's just a different network for some reason. So the devices actually like have this commissioning mode, and if you've commissioned it once, it probably won't be in commissioning mode a second time. Yeah, I did a hard reset on it, and I've been able to, yeah, exactly. So I have another Eve device, so I'm going to try like straight out of the box because they come in a pack of 3. So I'm like, here's one that's never been touched. Yeah, yeah. So I think if you, there's all this complexity. So say you have Google Home as well, like you have to get Apple Home to tell the device to go in commissioning mode so the Google Home can commission it separately. Yeah. And then you have 2 things that are controlling the same device. Yeah. It's just. Yeah. Home Assistant is on one, there's a lot of stuff that's touching everything. So I'm like, something's going on. So I'm going to find out because we're going to have a customer that's going to have the same problem. They're going to be like, how come it doesn't work? And be like, oh, it's because you have to like tell Alexa to chill out because your Google Home is trying to interact with your Apple thing. Yeah. Yeah, and the other beauty of having it implemented in CircuitPython is that it's all open source. You can see what's running on the device, and it's Python, so it'll be easily hackable. Yeah, I would like to see like what it's doing while it's not working. That'd be nice. Goodness, yeah. Yeah, and that's why the like iOS chip tool app was really helpful. It had better logging. Yeah, it's cool, but like none of the things I have, I can look at a REPL. Sorry, it's a little box that's a motion sensor. There's no screen. Yep. All right, well, happy hunting, happy hacking. Thanks. Yeah, check out Deep Dive, assuming I don't have a baby between then and now. Yeah. Which will be more and more of a caveat. Yeah. Hey, I just got to have I been pwned. Yeah, sorry. Hey, everybody. If you have an account on archive.org, change your password. I had one, yeah. We all do. Everybody is about to get an email. From floppy disks. 31 million people. Yep. All righty. Next up, Scott, we're going to go to Jeff. Hey Jeff, what you got going on?
So I've been working on a little project. It's here's the real thing. But I've been working on this thing that we're calling CircuitPython Audio FX. The Adafruit store for like as long as I've known you guys have had this audio trigger, and I guess it's based on some terrible old chip that you'd rather like push into the lake and set it on fire. It doesn't
support MP3s, so like
and it doesn't support MP3s. Yeah. So the idea is to recreate that functionality in CircuitPython. But I started by doing something more exciting than MP3 support, which is polyphonic support. So the basics are very similar. You put files on your USB drive with special names, and then you activate them by pressing the buttons. And so like if I press this one, it's going to play a sample from a random selection of samples.
Track 1, random 4.
And then this one
Track 2,
just plays the same thing each time,
track 2,
but you can play two of them at once.
track 2,
Ooh.
random, track 2.
Which you could not do before.
Which you could not do before. So this is not like a drop-in replacement for the other one, because it has like these precedence rules when you try to activate more than one thing. But it's really fun to build this with the Pico 2 here. I've got a I2S DAC from Amazon, and then just some buttons. But you could use whatever you wanted that is gonna ground a pin to control it. And this, I think it's over there. It might be over there. This guide will go live soon.
I have to.
And
because it's like
everything about it.
I wanted to replace the VS1000 for a really long time, but I needed a chip that was that could play multiple high quality MP3s polyphonically, which cuts out, like you can do it with a 7051, ESP32, and some high end STM32s. But the problem is I also needed to be as inexpensive as the VS, and the VS1000 is like $1.50. So that really,
a good price.
Which is because it's a very specialized chip. You can't run any code on. Well, you can run code on it, but it's really minimal.
And you can't open source it, I guess.
And you can't open source it. The code's under an NDA, and it's like frustrating. People are like, I want to hack it. And I'm like, I can't give you the code modifications I made because I modified this NDA code. And I just don't want to deal with it. And again, it doesn't even support MP3s. So the RP2040 was the first chip that I remember I said, go try to do polyphonic MP3s, and you were like, yeah, you can do it to whatever.
Yeah, you can play 2 lossless quality MP3s at once, or more of them if you use a low bit rate, like 32 kilohertz.
Which you could do on
this one will do up to 4 MP3s.
Yeah, so you can do it on the RP2040 because it wasn't good enough. So finally, I have all I have to do is add an I2S ADC on the end, or DAC on the end, and I'm good to go. So basically, squish these two boards together, and I can make it cool. And you can reprogram it with CircuitPython, but it'll come with firmware ready to go. So thanks for proving that this is possible.
Yeah, it's really fun to play with the audio stuff, and it works really good. I run into one minor bug that I filed today in the core. You can get a little blip of some other audio file when you switch audio files, but
that's a little. Well, also looping. I was like, can you optimize looping? So there's a couple of things I was like, hey, can you do that?
So when a sample is literally looping, it does a good loop. I'll hold this for a second and we'll listen to it.
Track 4 hold loop, track 4 hold loop, track 4 hold loop.
But when it comes to playing sample A and then sample B and then sample A, that's going to be a little bit different and have some more latency. But looping one sample works pretty well as long as it's designed to have that little bit of silence. You don't notice it. If you tried to make a continuous sound, I think you'd notice the sound cutting out for a fraction of a second.
Yeah.
If you've got any silence at the end of your loop, it sounds just fine. And
that's
design your samples that way.
Well, we'll see.
All right. I like your approach on this too, because the end user, maybe they're just doing costuming, or who knows, you can control it with file names. And MP3 is out of patent, so we can do MP3s. So there's a lot of good. It's all things are aligning right now.
Yeah, I'm imagining you would make some interactive audio museum exhibit with this.
Yep.
Would be another possible use. All kinds of stuff that you could do. So look for that guide. It'll probably go live within the next day or so. But and then we'll come back and do kind of the more exact version of Audio FX and see how close we can get to being a drop-in replacement.
Yes.
Alrighty.
All right, good proof of concept.
Good work, Jeff.
See you later.
Thanks, Jeff.
All right, Liz, what you got going on this week?
So I have a Gamepad, which shouldn't be that big of a deal, but it's plugged into a Feather RP2040 with USB host. And so what I'm doing is basically kind of a hacked turbo button, which back in the day, Nintendo had this old school controller. When they hit a switch, then you could spam the A button. So right now, what I had to do for the code was I have basically the RP2040 host acting as a pass-through. So I have this Gamepad test here to check I've got the analog joysticks going, all the buttons going. And when I do a button, right button, left button together, you can see now the A button's just going and I'm not pressing anything. And then if I press it again,
we'll trigger it on it'll do the key presses for you, high and low. So it looks like you're blasting.
Yeah, exactly.
Yeah, that's good for games where you have to really quickly move, but maybe you have carpal tunnel because you've been writing so much code your whole life.
Exactly.
Right.
Or knitting or piano or anything like that.
Right.
So yeah, there's going to be a guide on this. I'm just wrapping up. It's going to be kind of like a walkthrough of like how you would read your HDR ports from your controller, because each controller is different, and how you would set up your own shortcut to do your own turbo button.
Okay.
Yeah.
Alrighty.
Cool
Thanks
beans.
so much, Liz. And thanks for covering some show and tells.
Of course. Yeah. Happy to.
Thank you.
Okie dokie, JP, what do you got going on?
Ooh, it's Spooky Land.
Yes.
Ooh.
Yes, let's get in the mood, right? It's October, and I have a little bit of a plan to do a something to scare the heck out of trick-or-treaters. So to demo it, I thought I would have a hanging skull here and then another themed skull. What you may have just heard is I crossed the beam.
Okay.
And when I cross the beam, I am triggering a solenoid that is right now not letting any air out because I have a safety ball valve on there. So what I'm going to do is allow air to go through this solenoid valve.
Safety.
So this has what about 40 psi right now in this gallon tank. So you can get a bunch of shots out of that. And so this is what would happen if someone got near the brake beam or the distance sensor. Obviously, we don't want to be firing at people, so this would be pointed at a prop or a zombie wig or something like that, or just to make the noise. It doesn't have to actually aim at anything in particular. So here's what the sound and visual should be like.
Oh.
So these are something you may recognize that sound from theme parks. There's a lot of hydraulic or rather pneumatic stuff at theme parks that blasts in rides to make water effects.
Yeah.
Things going off, just to disperse a bunch of fog, things like that, as well as confetti cannons, t-shirt cannons. They're all kind of basically the same idea. So we'll blast this one again. So that's what it'll look like, and ideally scare the heck out of people. So I'm going to talk about that on the show tomorrow, show a little bit more of the build. Last week I kind of set up what the pneumatic system looks like. Now I've got all of the controller parts in here, which is basically a power relay shield or power relay feather wing and an RP2040 prop maker feather. Those are kind of the two things. And then over I2C, I have our little the L53L1X distance sensor that can go out to pretty far. You can set this one out pretty far. So.
Nice.
Good work.
Okay.
Yeah, I like that you're building your own. Like, I'm just gonna stay home and be my own carny.
Yeah.
It's interesting how old pneumatics are as like a prop technology. I mean, it's like ancient. Like if you go to like on the Rock, it's like this is stuff from like the 60s, 70s, and it's like they're like, look, all we had are like magnetic switches and pneumatics, but we're gonna like do what we can.
Right, and everything comes out of there for sure.
Right. I remember in like, I don't know, because I lived in Florida.
Have a wheel,
I was young,
would, like trigger,
and it was like
pneumatics.
you would hear like the whatever the exhibit doing stuff.
Yeah, absolutely.
Cover it up with other things.
Yeah, there's a variation on this where you can get I've done it again. You can get bidirectional valves so that you can move pneumatics sort of forward and backwards. So a lot of things that like pop out and scare you and then come back down will be this plus a two-ported valve. So you can.
Well, pneumatics are fast. There's nothing fast. I mean, like to move things quickly. Even now, of course, people use.
There's a good sound from it, and you get air. So there's like a lot of things that go along with it.
Yeah.
All right. Thanks so much, JP, and see you tomorrow on JP's workshop.
Stay spooky.
All right, Erin.
Hello.
What you got going on?
So I am working on a project for Maker Faire. Maker Faire Bay Area is next weekend.
That's right.
So this is the project that I'm working on. This is an illusion. So they've given me a little tiny dark closet to fill up with lights. And I'm going to be bringing this there. It has a one-way mirror inside so that when and then I have lights on both sides. This fiberglass tree is two-sided. So there's another one identical to it on the other side that you can look through the window and kind of see through both trees. So the idea is that we can have a person stand on one side, stand on the other side, and then there's a two-way mirror inside there. And when the lights are lighting up one person on one side, they'll see their reflection. And when they're lighting up the other person, they'll see the other person. And then as the lights fade back and forth, it will blend the two faces together. So if the two eyes are lined up looking directly at each other, the effect that you see, the illusion, is that you tend to blend into the other person. And now this is, I'm using wLED, I'm using seed pixels and a couple of cutie pies to run this thing, which has been kind of fun. wLED is very much about like pre-canned animations, but I've been really like digging into getting them, making custom palettes and really making, getting it to do what I want. And I'm going to see if I turn off the lights, if this, it's a little hard to photograph because you kind of have to get your face right in there, but let's turn off the lights and see if we're able to.
Ooh, I see there's a skeleton.
Yeah. He's my friend who's been testing this with me. To the screen here.
Oh yeah. Oh, that's cool. Yeah.
And there's my eyes right there. I can't get them right at level.
We're not going to get synced up, but they use
that conveys the point. That's really cool.
It is pretty cool. And I want to have an audio element to it as well. And so this is what I've been working on this month. And Maker Fair's next week, so I'm also thinking I might put lights on the ceiling and see how much time I have to build this thing out. But it's a lot of fun. I actually found this fiberglass tree on Facebook Marketplace, and I went down to pick it up, and it turned out that it was, if you have time for a little story, it turned out that it was being sold by this guy who does all the Christmas decorations for all the Macy's in California. So I went in there and this warehouse was like Christmas town. Like there's these 12-foot tin soldiers, fiberglass, the giant Santa thrones, and then just racks and pallets of Christmas balls and decorations. This machine that took a flat ribbon and turned it into one of those garlands that looks like fur. I never knew how they made those things, but apparently there's only 3 of these machines in all the world. And he showed me how you just turn it on, and it made 50 feet of garland, just by it was amazing. Anyway, quite an adventure. So.
And this is why Facebook Marketplace
sometimes there's a win.
Is amazing.
Sure.
All right, nice work.
Thank you.
Thanks, Erin. All right, Tim, what you got going on this week?
Hello. I have been working on a little spirit board demo for the PyPortal. It's running on this one, so it will wait for you to touch the screen. So I'll poke it, and it will do its thing. And it will tell us the first message. And while it's running, I'll tell you a bit about it. Unlike the traditional spirit boards, instead of messages coming from the spirits, these ones are coming from Adafruit.io, foreshadowing from the other side of my screen. So you can kind of just add a data to it, and it can either be a string or a comma separated one. So I actually have a couple of them loaded in there now, and when it turns on, it will fetch the latest data and then let you kind of cycle through them. So the next one will show the next message, and then you can put however many you want in there, and it will just go through them. This one is on a PyPortal, but I've tried to make the display.io code generic enough that it should also port to Featherwings, TFT Featherwings, with an ESP32 feather inside, or S2 or S3, any of those should all work. And I'll pop this open while it's running, and you can see the list of messages there. So super easy. You can just put in whatever things you want. And then I'll probably make a backup for it. So if it's not online, it will just fall back to kind of a random list that it can keep locally inside the code or whatever.
Yeah, we did some projects like that where if there's, you just set something and it would look at a local text file. So you can do tests and stuff like that. I like this because it's cute. It's you captured a little ghost or a spirit in the digital world, and it's playing through the ether to get its message out. So kind of like Ghostbusters when they captured all the ghosts and put it into the machine, and then they let them loose. All right. Well, thank you so much, Tim. This is super cute. Are you going to have a guide or a thing or a something for somebody to look at later?
Yep. We'll have a learn guide on it.
All righty. All right. Thanks so much, Tim.
All right,
yeah, for sure.
All righty. And let's see. D. Cooper, are you here? All right.
Hey. Oh, y'all hear me? Sorry.
Hi.
This will be my first time here. So thank you all so much for sharing all the projects. And everything. Really cool so far. I have a little one I've been working on for a long time, inspired by synthio with CircuitPython. And it's just expanded over the months I've been working on it, and here it is. I'll get a little dual in there. So this is a little board. Y'all can probably already hear that, can't you?
Yeah.
So it's using a separate touch controller to do a keyboard. There's an amplifier. There's I2S input, output, MIDI, etc. I kind of wanted to do a do all, do anything kind of audio board. And that's what I have here with the character LCD, which is difficult to see on screen. But and I have it. It's actually really cool. I discovered this recently. Supervisor within CircuitPython. I found it was out that you could actually load different programs. So I have multiple apps on that are dynamically loaded by just changing what the primary code file is. I thought that was really cool. So here I have a synthesizer app, and this is actually using the experimental audio delays pull requests that we've been working on lately with Mark Gambler21, I believe. Yeah. So you'll actually see, and I shared some of this in the Discord recently, but you'll hear some of that delay in action. Ooh, pretty.
Yeah.
And so there's a lot you can do here that's polyphonic up to, and this is using a Pico 2, even though I do have other boards that use the standard Pico, but of course the Pico 2 has been pretty awesome for audio effects here. And yeah, it does a lot of cool stuff. You use arpeggiators, all this. I've been working on developing a lot of synth-based libraries that I've been sharing recently. So here's a cool example of like an 8-bit kind of sound.
Oh, that's cool.
Yeah,
yeah.
And there's a lot you can do with this, and I won't go too into it, but
yeah, I love it.
So I guess when you're ready to share it with more of the world, you can put something up on Playgrounds. If you put a video up online, let us know. I think a lot of folks would want to make some music with this, because it sounds like you put a bunch of work and effort into it, and that sounds great.
Yeah, sounds great.
Totally. Yeah, I have a 10D as well, which hopefully one of these days this will make it to it. It's a lot. I envy you guys, because it's very difficult to when you have a big project with a lot of hardware stuff going on to make all that work.
But it's worth it. Well, we've been at this for about 20 years. It's worth it. It's nice to have something you make go into someone else's hands, and they do something with it you weren't expecting, and then they make something. Like making a tool that allows people to make music is really nice, because you'll hear something. So I know it's a bunch of work, but have at it. When you put it in your Tindy store, we'll help promote it and help get you sales and all that.
And that's another big thing. I have done some other projects, but they're all in C++ and kind of, are difficult to get into. I've been really excited to use CircuitPython just to give users an opportunity to quickly get in there and play around with
this is totally, by the way, like what the goal of CircuitPython synthio was, to allow people to make little synths where you can actually tweak the settings and modify it without having to do this massive recompile, because that's always like
the first 5 minutes you could do something, but then if you really want to dig in, you can spend months and months.
Yeah, because people are always like, okay, I have the synth code on some microcontroller, but I want to use like a distance sensor, I want to use like capacitive touch, and it's like it's going to get really complicated really fast. So I'm psyched that I'm glad you did this for me.
Very cool.
It's cool.
Yeah, I'll share the code eventually. It's obviously going to be a little bit big, but all things considered, compared to a fully, bespoke C++ synthesizer firmware, it's actually pretty great to utilize all these tools.
Yeah.
All right, we'll keep coming back and showing this off, and we'll help get the word out.
What's cool is also you can the synth can last forever, because you can just distribute like the binary and all the code. So it's like, if you want to modify it, it's not like, oh my God, I have to find some old compiler, right? In like 10, 20 years, somebody has a synth and they want to hack it. If you want to hack like, synths from like that I've seen that are hackable, it's like really hard. You have to get like a special kill compiler, and you have to get like these libraries, and it's like a nightmare, but you can actually have it all. It's like allows for survivable code.
Definitely.
All right. Well, thank you so much.
All right, we wrapped up just in time.
Yep. All right. Thank you so much, everybody. And thank you for making this our favorite half an hour of the week every single week. We'll see everybody next week, 7:30 p.m. Eastern Time. Come by, show and share your projects and more. Ask an Engineer starts in about a minute or so.
Thanks, everybody.
Bye, everybody.